Hey guys, welcome back to part 2 for Node, Kafka, and Go. In this video, we're just going to be finishing things off and creating our Go portion of this, so stick around. Okay, so let's start off with our Go portion of things. So let's go over here. We still have our Docker compose set up with Kafka and Zookeeper. So let's cd out over here and go to our Go folder. And inside here, we need to get one package. So let me show you what that package is. If you go on GitHub, there is this package called Segmentio Kafka Go. So I tried looking up like other Kafka clients too, and the other one seems sort of complicated compared to this. It seems very simple to use. They have a comparison with other popular Go Kafka clients too, and they give their reasoning as to why they might be preferred. So definitely go out and research, but I'm going to use this one over here, and they have good documentation as well. So all you have to do is copy this domain and then go over to our GitHub, to Go, and say go get -u, and we want to get the Kafka Go package over here. Cool, so that generated us a Go sum file, and inside Go mod we can see we have Kafka Go over here, which is great. So now let's go back to our Go file over here and let's paste this guy in here. And now let's first make our topic. So let's create a couple of constants, and this one is called prime topic is equal to, actually no, this is the exact same as this over here. Luckily, TypeScript and Golang have roughly the same thing. They just don't have ending trailing commas. So let's do that. And let's create functions for creating our consumers and producers, right? So let's create a function. So function new Kafka writer, and this is going to take in a Kafka URL and then a topic, and both of them are of type string, and it's going to return a Kafka writer, and over here we just have to return our address. So just say Kafka, let's say Kafka.writer, and then over here it takes in a adder. Okay, so there seems to be a little bit of confusion, probably not be able to find this. So it's imported but not used. Let me just do go mod vendor, and this will vendor in our dependencies inside that folder. And then let's just do a go mod tidy just to get that in, to clean anything up. So now this should be fixing itself. There we go. So it fixed itself. So now we can add in our address, which is just going to be a Kafka.tcp, Kafka TCP, and we just pass in the Kafka URL over here. Oops, the URL over here. The next one we need is our topic. So this one is also passed in. So we'll say topic. The next one we need is a just a balancer over here. So this is just going to be the default one. So Kafka least bytes. And then finally our batch timeout. And I'll show you, actually let's do this right now. Let's just comment this out for now, and I'll show you why we need that later on. So now the next is we need our consumer, or in this case the package calls it our reader, And over here I'll say new Kafka reader. And what's it going to do is just take in the list of brokers. So new reader is actually a function which takes in a Kafka.reader config, and then it takes in our brokers. So our brokers is going to be the list of URLs. So it's just going to be an array of strings. Point that over there. We do need our topic, and we also need our group ID. Whenever you're consuming, Kafka needs to know what group ID you belong to. So group ID over here, I'll just need to have add that in as well. So group ID, and then we don't need a balancer. This should be it. This should be everything we need for a very simple basic setup. Let me copy that, make sure the case matches. Okay, cool. So the group ID over here is a string, the group ID missing. Oh, okay, cool. So now let's finish the rest of this off. Why is this complaining? Cannot convert reader config to new reader. Oh, okay, new reader. Kafka.new reader. Cool. So now let's create our Go code over here. First, let's create our writer. So our writer, we just have to say new Kafka writer, and over here it's just localhost :29092. And the place we can go see that is in our Docker Compose file over here. We have our Kafka ports mapped over here. So that's how we get that. And the second one is our topic. So we'll say, where is it? It's our prime topic over here. So prime topic over here. The next is we're going to asynchronously consume on a different Go routine. So I'm going to create a consume function soon. Let me just comment that out. And let's first focus on writing to our queue. So I'm just going to create first of all, I'm just going to defer the writer dot close. And now I'm just going to create a simple for loop. So for I is equal to 0, and then there's no breaking conditions. I'll just keep incrementing it forever. And now let's create our key. So our key is equal to fmt.sprintf, and it's going to take in a number. So %d for decimal. So that's going to be our key. And then our message is something we're going to construct. So Kafka.message. And over here, it's going to take in a key. But all these things are going to be bytes. They're not going to be strings or anything. So we need to parse this or cast this. So we'll cast our key as bytes, and then our value also as an array of bytes. And in here, I'm just going to say, I don't know, fmt.sprintf. Your message is decimal. Let's just pass in the number here. No, so let's just put in a text. Your value is %d. And we're going to pass in our I value. So one thing to note is that usually in value, you will pass in a JSON format, just because on the other side, then you will parse that as JSON and you'll have much more valuable data. Here it's just plain strings. So one thing to remember is you can send JSON as well. Make sure you convert them into bytes, and then you would have to parse them or marshal them back and forth. So now the last thing is we need to use our writer to write our message. So we'll write our message. It takes in a context, so we'll just pass in a background context, and it's going to take in our message, our Kafka message. So now all I'll say is if error does not equal nil, then fmt.print, or I should say log dot, well, what do we have? Log.fatal We don't want a fatal because it's gonna exit. I guess we can exit. No, let's just fmt dot print dot error f. Nope, that's not it too. My God, taking up so much time. Print line the error. Cool. Otherwise, else we're just going to print out that we've produced it. So fmt dot print line. We have produced message with key, with the space, and we'll pass in our key over here. Cool. So that's going to continuously send our message. One thing we're doing, we need to consume back from nodes. So we said we would create another function. So function consume over here. And now over inside consume, we're just going to create a reader. And our reader is just we're going to reuse that function. Where is it? New Kafka reader over here. And inside here, we're going to pass in roughly the same stuff. So localhost 29092. We're going to pass in our topic, or actually, no, this is our group ID. So we'll just say group ID is our Golang server. And then finally, our topic is going to be, topic that we're going to be listening to is the update topic. Because we're going to be sending messages to the non-update topic, and then we're going to be listening to the update topic. There's different patterns out there that you can follow. I think I follow this one. I think it makes the most sense. It's easy to know, like, hey, because once you send something to a queue, usually sometimes you're waiting for a response. And if you're waiting for a response, then you rather suffix your thing with update. So reader.close, we're going to defer that. And then we're just going to add this inside a for loop here where we're going to try to get a message. So error is equal to reader dot read message. And it's just going to take in a context again. So context.background. And then we just, if error does not equal nil, then just fmt.print line our error. And then finally, we're just going to fmt.print line our message. So one thing with our message now is that if we do message dot, key, you notice that it's an array of bytes over here. And if we go down to our value too, it's also an array of bytes. So we need to parse this, right? So one thing easy that you can do is just say, hey, this is string over here. That'll parse it as a string, and then we'll just say string again for message dot value. Cool. So that's pretty much all we need. The last thing we need to do is we need to uncomment this out over here. And now I think we can start testing this out, right? So context over here is being annoying. This will work. This will definitely work. So let's go over here, create another terminal. Let's make this one small. So Golang is going to be sending our messages to the topic, and Node is going to be listening and responding to it. So what I'm going to do is I'm going to just cd into Node, and I'm just going to say yarn start over here. And at this point, I'm just going to zoom it out just a tad bit, just so my terminal has more space. Cool. So let's make this bigger as well. Okay, so let's see what's wrong. Object is possibly null. Okay, cool. So let's fix all of these right now. So value, so if we say question mark over here, and question mark, and is that it? I think that is it. Yeah, so let's try to run that again. Oh, okay, so it can't be undefined. Yes, I totally forgot. So I'll just do that, and then even though it's not going to be undefined, the producer totally could send like a blank a message and a blank key. So that's totally fine. Value could be null. What line is this? 26 over here. Yeah, but that's fine. Okay, so we want to short circuit that over here as well. And now clear. I think now this should work. Oh yeah. I need to run our main function. So over here, our main function. So we just say main dot then console log success. Cool. So at least we know we don't have any TypeScript errors now. Cool, so we made some connections over here, and we can see Kafka doing its stuff too, logging its stuff. So it's trying to connect to probably a topic that doesn't exist. So it's backing out a little bit. Let's see, there we go, success connected to prime topic. Okay, so now over here on Go, we'll just go run dot. And let's see it do its thing. Hopefully Go doesn't have any errors besides that, but that's just my editor being wonky. Cool. So there we go. We have produced messages with key 0, key 1, key 5, and over here we can see those same messages coming in. And now after some time when Node makes a successful connection to the producer, as a producer, and then a Node will listen back again and it will get the messages. So you see now that the messages coming back are either by themselves or chunked together. This is mainly because I put this inside a random wait. So it's randomly waiting for each promise to successfully resolve in under 10 seconds, from anywhere to 0 to 10 seconds, and it's sending the message back. And we can see it's on partition 0 over here. What you're going to notice is that we're going to receive all of these in order. Like, that makes sense, right? We're just receiving it in order because we're not really putting any delay here. But the way we're getting it back over here is like we're getting key 67 and then 62. We should be getting 62 and then 67. And that's mainly because over here we put a random wait time, and then we are waiting for that to resolve for that wait time, and then we're successfully sending the message back. The key we're sending back is like a math.random to string over here. That explains this decimal. And yeah, that is pretty much it. So now you can go out of your way and make this more useful in your tech stack. So what usually would happen is value would be an array of bytes, but it would be a JSON object. And this JSON object would contain like specific information about, I don't know, registration or something related, something for like long processing task. So and then you would receive that on the node end, and then instead of saying .toString, buffer also has a property called .toJSON. So you can get a JSON object back from toJSON over here, which is pretty cool, right? So now you can get your JSON and you can play with it as a regular JSON object. So that is pretty much it for this video. I hope everyone found this super helpful. I had a lot of fun doing this. I wish I made something a bit more useful than this, but it generally shows you how to set things up, and you can totally create your own applications the way you want to with this stuff. So I hope everyone enjoyed this video. If you did, show your support in the comments section. Drop a like. Let me know what you want to see me do next, and I will try to make that happen. So everyone have a great weekend, and I will see you in the next video. Peace.